Thank you all for a very warm welcome, especially the front row that somehow think that I want to be something useful. Spoiler alert, I'm not. So, well, so how many of you already heard of GraphQL? Raise your hands. Oh, okay, why am I here then? No, okay, I'm gonna go. Okay, so, well, I'll skip the introduction of GraphQL, but I really wanted to tell you more about that, especially the Facebook part. But since, well, you all know it, well, and you know Facebook, well, that doesn't make sense. So let's start right away with why I'm talking about GraphQL. Well, in the first place, we had a problem. I mean, I personally have more than one problem, but in this specific scenario, we had one problem. But before that, yeah, it's quite a bold animation, right? Let's introduce the new home of our app. So it's in portrait, a list of elements which are slightly different one from the other. But when you go to landscape, we wanted to mimic the experience of a newspaper. And on tablets, it's even more complicated because we also add side columns. Don't look at me like that. It was designer's fault, not me, okay? So, in order to get all these informations in only one call, we basically had only one option, which was using GraphQL. Why is that? Because with GraphQL, we could get all the data that we need right away, shaping the query based on our own needs. Because, of course, we have some constraint due to the platform, due to the technology, due to how we develop, that maybe the iOS team didn't have. So either we specify a very complicated common endpoint in which we pass parameters so we can have slightly different responses, or we give more powers to the clients. And if you add web into the mix, well, you know, it's going to be even more complicated. So we decided to go for GraphQL. But, well, I can't really say that GraphQL should replace REST or RESTful services in any way. Okay, so never think that they cannot coexist. Actually, we have them both in our app. And most of our services are provided by either both of them or just one, based on our needs. They just solve different issues. Okay, so why I say that? Why I say that they solve different issues? Because they are actually very different. The biggest difference is that we are talking of a standardized set of functionalities that can be used to architect your own network layer to a language that we use for queries, like SQL. Like it would be like more or less comparing Kotlin. No, well, yeah. Kotlin, which is amazing, and something that is not Kotlin, which will not be amazing. So if you're not using Kotlin, well, use Kotlin. More on that later. So there is another thing that actually is important here. REST doesn't really care what is running on. I mean, you can put whatever you want under, and that's fine. Well, if you try to do that with GraphQL, well, they're not really happy, like at all. It only works with HTTP, which is fine, I guess, at some point. And, well, with REST, we can decouple APIs from the clients pretty easily. Well, GraphQL comes with an API, so not decoupling much. But, well, they're different, okay? Another thing that actually distantiates them even further is the fact that REST tries to leverage the protocol as much as they can. That means that they make use of error code, content types, cache, and all the things that is available on the underlying protocol. While GraphQL, it somehow enforces their own conventions. So, for instance, you can decide that an error might be 400, 401, 404, or even just say, yep, the response is empty. So, whatever you want, basically. So again, you're sure that when you interact with a REST service, the response will be that. With GraphQL, since you have more power on the client, you can actually tweak it a little bit more. So it depends mostly on what you have to do. Also, well, this is actually more like a minefield. So where versioning is a problem, is always a problem. It's not an easy task to solve. Like network connectivity or other big problems like, I don't know, fragmentation on Android, these kind of issues, more or less. Well, REST actually have a very smart version to do that, and well, it should evolve pretty cleanly. But well, I've seen several times API that were like, okay, this endpoint is for version 1, this other is for version 2, this other is for version 583, and you never know how to use it. I mean, there are versions, I guess. What is this, the last one? Or they somehow forgot to update the documentation, or the documentation mismatched because they forgot a v2 somewhere. Of course, you can use headers. You can use parameters, but hey, it's going to be much more complicated. And that is more on the server side, right? While GraphQL, since it gives a finer control upon what you're requesting, actually makes our life somehow easier in that sense. Because you can mark what exact field is deprecated and what other field you should use instead. More or less like we can do with Java doc or Kotlin doc, maybe in the future. So another big issue that GraphQL was trying to solve is the fact that with a RESTful API, you actually get the standard response. Of course, you can tweak it a little bit. You can have your custom endpoint for your own platform. You can do a fair amount of things to make things easier. But if the data that you need is on two separate entities, like one is user and the other is content, well, there's not much you can do there. If your API is designed in this way, that is what you're going to get. While GraphQL has been somehow projected with client performances in mind. So this is why it works in a different way. Because the idea behind GraphQL is to make a single response, a single request, to have exactly what you need at the specific time you are requesting it. Well, this somehow is a point that I will credit to REST and RESTful services. Because since they leverage the underlying protocol, caching comes almost for free. While with GraphQL, well, it's more like, well, that's your business. Do that as you prefer. So from one side, we have the possibility of caching data really easily. On the other, we have the freedom to cache it as we want or as we need it. And of course, the last thing. When we want to parameterize something, well, GraphQL is a query language. So all the parameters that we might need are already taken into account. You can pass a parameter, you can pass two, but actually, it's a small JSON. You basically pass this parameter together with your query. But it's not inside your query, it's not inside your URL, it's not inside your headers. It's there. It's part of the content that you're sending, separated from the query. While, well, on REST, well, you have query strings, you have parameters, you have headers, but they are somehow polluting what you're sending. Oh, well, not really polluting, but they're making it slightly harder to understand when you are looking at, well, with a human eye. And of course, something that we just mentioned, the fact that if we have two entities or more entities, we have multiple endpoints. That means that we have to make more queries, more requests. And that's actually was an issue for us. Because imagine that our, well, normal use case is someone that is commuting to work. And usually, when people in New York commute, they are on the subway, which is underground. And, well, that is a problem, because the network cover on New York Wi-Fi is, well, yeah, no. Let's just say no, okay? So for us, it was a problem. How can you solve, well, not really solve because it's a very complicated problem, but how can you make your life and your user's life easier? Well, we switched to a single endpoint, and this was possible thanks to this specific technology. So, of course, it could have worked with other solutions, but this one would actually help us right now. And it actually gave iOS the same thing, and the web the same thing. Even with different constraints, we only had to manage one single backend. And also, unless you have different endpoints once more, or different parameters, you actually have a unified response no matter what client you're connecting from. So if you're connecting from Android, you get this. If you're connecting from iOS, you get that. I mean, with the vast majority of REST APIs around, this is what you get. While with GraphQL, every client is actually free to ask for what they need. Imagine that the feature is slightly different on iOS and on Android, because we might want an image while they don't display it because they prefer more text. They don't need that. Why should they actually take that into account? We need that. We request that. They don't. Well, that's fine. I mean, don't request it. So we have separate sets of queries based on the fact that you are on a platform or on the other. But actually, what is GraphQL? Or better, how is composed GraphQL? Well, we basically have two elements of a GraphQL client. Well, I suppose that on the backend there are more, but I'm an Android engineer. We are, I guess, Android engineers. So, well, I don't know anything about the backend, so I suppose that we all are more interested in Android, right? No? Okay, there are two people there that are not Android developers, so we don't care about them. 3, still. How many of you are not Android developers? Well, that's too much. I mean, come on, really? Okay, so for all the Android developers or people that are interested in the best platform, which is Android, once more, well, this is what we get. So the first thing we need, or the last, based on how you want to implement it, is a query. So you have to know what you're actually going to request. Because if you don't know what you're going to request, well, you're not using GraphQL at all. But in order to know what to request, you have to know how your endpoint data is actually structured. And for that, you have a file that was way too big to actually show it here, and it is called schema. It's basically a very big JSON file that describes each entity, how it's made, what data and what kind of type is included in this entity, and how this entity is connected to everyone else. More or less like if you create a database and you define everything as a SQL query. Okay, you define that. We have a JSON here because, I mean, we love JSON, right? But this GraphQL file is not really supported into Android Studio. I mean, you get some syntax highlighting, but you can't really have much more as of today. So you need some other tools that help you write your queries. So the one that is that more or less everyone knows and use is GraphQL or GraphIQL. I never really understood how it's pronounced because they have like somehow a very bold I. So, well, so usually this tool is hosted on your backend. So you actually have it as web interface, as a website with a bunch of edit text, very big, in which you actually write your query, pass your parameters in another edit text, and on a text view on the side, you get the response. Why this is important? Because since it's on your backend, it actually knows how to fetch the schema. So when you type the query, you not only get syntax highlighting, but you get documentation, and actually, you get to know if your query is correct. Because if something is not working, it will tell you right away. Even if you declare a parameter and don't use it right away, it will actually underline it in red and say, hey, this parameter is not necessary now, so why are you declaring it? So another tool that I discovered recently is the GraphQL tool. It's quite complicated to pronounce. So this works in a slightly different way. It not only gives you the same thing that GraphQL brings to you, but also provides you the possibility of connecting to a different endpoint. Use tabs, more or less like Postman, okay? You can connect to different endpoints, you can get different responses, and well, it works pretty well. So, well, not everything is available as a website, but there are also some Mac, Windows apps. Well, basically, there are multi-platform apps that, well, I guess they're powered by Electron. So, yeah. And the first one is Altair. It's an app that works more or less like Postman, but for GraphQL APIs. The problem is that you have to provide both the URL of the schema and the URL of the endpoint if they are not set so that it can be fetched automatically. And another client that works with both REST and GraphQL request is called Insomnia, which I think is not because you lose sleep upon GraphQL or REST, but well, it was a nice name. And the last one is the only one that I found that was actually available as both website and desktop application, which is called GraphQL Bean. Well, they don't really, well, they're quite complicated to pronounce when they put graph in front of everything. But, well, all those tools can be used to actually write and debug your queries. So you know exactly what you're getting and if there is something wrong with the response you're getting. Okay, so, well, we happily wrote our queries. We feel much better. But at this point, we have to include them in our Android project. And, well, more or less like if I have a network request, I usually check if I can use retrofit for that, which is the standard, well, not the standard, but let's say the referral point for what concerns REST request. For GraphQL, we have a framework that is called Apollo. Once again, naming is a bit complicated, but, well. So, why should we use Apollo on Android? Well, Apollo brings us all the features from GraphQL, of course. So, compile time safety. Why compile time safety? Because basically, we just saw that with our tools, we always know if our query is right or wrong. And, well, maybe we didn't really copy it well. So when we passed it into Android Studio, we forgot something. And as soon as we compile with Apollo, it will tell us, well, no, your query is wrong because the schema that you passed me told me that, well, what you input was actually wrong. So, well, it's much better to actually have that failing at compile time than having it fail at runtime. The other thing is providing something that GraphQL didn't provide to us, which was caching. It's provided as an external artifact, so we are not forced to use that, but it's available. So it's covering something that GraphQL was not covering in the first place. Of course, Apollo is open source, and it has behind a huge community that is working quite a lot on this framework. Because Apollo is not only available on Android, but is available also on iOS, on web, and I guess for backend. Now, there is a backend for Apollo, yeah, definitely. But the last and most important thing, which is something that I didn't know it was available for retrofit until, well, Nicola talked about Swagger and the code generation, is actually that, code generation. So with Apollo, you get that for free. How you get that? From your query, they generate the types that matches exactly the response you get. Right that. Yeah, there is only a slight problem with that, and it's that all that code is Java. Yeah, I know, right? Don't know what to do about that. They use Java Poet. That's it. So, how do we include Apollo inside our project? Well, the first thing is actually adding the class path of the project, which actually is on JCenter. So you need to add JCenter and the class path. Well, anyway, and that will do the trick. After that, you switch to the build.creator file of the module where you actually want to use Apollo and add the plugin among the others. If you didn't notice, well, what is that? Sorry. Yep. This part here is really important. So if you didn't actually add the second and third plugin, go and do that now because they are really important. Also the fourth, but especially everything from Kotlin. Yeah, I still love Kotlin, I'm sorry. So once we get the plugin, we actually need the dependencies. Because actually Apollo also provides supports for reactive Rx Java 2. It doesn't provide yet support for coroutines, but well, it's not that complicated to bridge from Rx Java to coroutines. Of course, not everything is amazing in Apollo, and it has a very big downside. The fact that once you include the plugin, you need to add the schema and at least an empty GraphQL file, otherwise it's not going to compile at all. So once you start implementing it, you have to provide everything it needs, otherwise it will fail. Let's switch about a slightly more complicated topic, which is testing. Why is that complicated? Well, because of course, we get compile time safety, but the only other reliable way to test what you get is actually using the mock web server. So let's see why I put the compile time safety in testing as well. Because what you get when you even try to run a test, but your query is wrong, is an error like this one. I cannot find the field that you just set. I need a properly named field, which could be this other one. So it actually helps us be sure that we wrote something that is syntactically correct. But, well, that's not enough, because we want to know that we can actually rely on the response. And the only way to do so is actually taking the response we get and mocking it with mock web server. Of course, there are other kind of tests, but are way more complicated on Android. And this actually has a few issues as well. So, why did I talk so much about testing? Because we had a problem. So, the problem we were facing is the fact that before actually hitting our backend, we will go through our CDN. And then, if the call we were making was not cached inside that, we will hit out our backend. So we somehow relied on the cache of our CDN. But in order to do that, well, we had a limit, an 8 kilobyte limit per each request. So, well, how can you actually be sure that we respect that? 8 kilobyte is not much when you have to send a wall query. We are requesting the data for a wall newspaper homepage. Everything that anyone is going to read needs to be specified in that query. And after the first iterations, we were close to 7.8 kilobyte. So, the only way we could assert that our request was actually down the 8 kilobyte limits, it was mocking the response and try to calculate how much each query was. So, well, we tried to use an HTTP interceptor, which somehow make the trick, but is not reliable. Luckily, in one of the recent updates of Apollo, they introduced the support for automatic persistent queries. So, how automatic persistent query works? Let's say this is a query, okay? So, what you're getting here in this query is basically all the, the data, the main data related to a movie, all the characters inside these movies, and a bunch of data about these characters, like the name, their homeworld, what species they were, and in what other films they actually appeared. Okay, so this query actually works, and is taken from the Star Wars GraphQL API that is publicly available, because why not Star Wars? So, when you got this query, it gets shipped with the request as part of the content. Of course, we mentioned variables, and this is how we ship them. So it's another node of the request. But actually, not everything about this request is really important. I mean, it's important once, but since we already talked about the fact that we have like the query inside our code, well, it's not going to change unless we change the app. So the only thing that actually can change in this request from one execution to the other are the variables and the operation name. Well, operation name is not really going to change, but the combination of variable and the name of the query we want to execute is actually helping us understanding what is the query, together with, well, the hash version, the hash number of what we send. So instead of sending the whole query, we just send 3 specific data, which is variables, the operation name, and the version of the persistent queries, and we can actually know what query to execute. So we were really down the 8 kilobytes limit, because our request was actually not much more than this. It only had a bunch of parameters more. So we were really, really not close anymore to the 8 kilobytes limit. And this won't change, because no matter how many things we request, this part will not change that much. Maybe the value of the parameters can change. The SHA will definitely change, but nothing else work under the hood. Well, when we make a request with automatic persistent queries enabled, we send the query hash and the variables and such to the backend. But the first time we do that, the backend is not going to know about this stuff. So it will send us back an error, say, hey, yeah, I didn't find the hash, so but please send me the whole query and the hash, And then I will save it and give you back content. And actually, enabling that on Android is really easy because it's just, well, it's easy. Let's start from that. So this is the declaration we had in the tests. So let's clean it a little bit, and we get the normal request we will make. Okay, we can add a bunch of interceptors, because Apollo also provides interceptors, but the simpler way to enable persistent queries is just provide a flag. As soon as you turn that in, automatic persistent queries will already be working in your client. And actually, even if your backend does not support automatic persistent queries, your code will not change because it will work anyway. Of course, it will make every time two requests, so you should actually switch it off, but it will work anyway. So there are a couple of tricks that I wanted to share with you before, well, the talk is over. And well, let's use this small query for this example. So we notice that we can actually request stuff. But you can also actually use aliases for what you request. Let's say that that on the backend they are fine with calling the ID of an article like source ID, but historically on Android we called it asset ID because we liked it more. So we can actually have our data type be named asset ID instead of source ID, because when you have very big objects, remembering how they're called, well, actually makes sense. Another thing that you really have to keep in mind when you're using Apollo is that this framework adds the type name everywhere. Even if you don't add it in your query, it will be added at compile time, because they need it for marshalling your response and to understand what they actually need to produce. So the trick that we found is to actually include the type name in every node of our query so that we could mock the response exactly how it will be executed on Android. Because if Apollo actually had that and we don't, well, if we don't have a field, we don't get the value. And as soon as we try to run a test with the mocked response which doesn't have a type name, well, Apollo's going to complain and we won't be able to actually execute our test. Because, of course, it said, well, I expect a non-nullable type name, but here the value is null for this node at this position. But, well, at the beginning, you couldn't really move the schema and the queries. They had to stay in a very specific place because the position was hard-coded, which is not really a big deal because, well, Apollo is not yet stable, so it's fine that there are some shortcuts. Now, you can actually decide where to put the schema and how to actually fetch the queries in your code base by specifying those instructions in the build.gradle file. And also, if you like getters and setters, because otherwise it will just say another instead of get another, you can enable the Java bean semantics by just using another flag in the Apollo lambda in GraphQL. And also, something that I don't know if it was me or something, well, I tried to compile a bunch of stuff while I was on the train, and I wasn't connected to internet, so, well, my build was hanging for like 10 minutes. That was like, oh, wait, this is problematic. So just remember to be online when you change something about Apollo, because if you use the npm version of the generator, well, it might need to fetch something. And, well, we're done. Thank you. Well,